Okay. Example 1 will be a noiseless channel. So in a noiseless channel, in other words, my channel outputs yi are always equal to the channel inputs xi. So let's let Sx be binary. Let's let Sy be binary. So the three things I have to specify are Sx, Sy, and probability y given x. If it's noiseless, what's the probability of y given x? It's 1 if y equals x and 0 otherwise. That's right.
Why did you put that condition if y equals x or 0 otherwise? The probability itself is defining that condition.
Well,
probability of receiving
yes.
y after sending 0 is 0.
That's right. So this is best interpreted as a function over Sx and Sy. So I can plug in any valid x and y here. So how should I calculate this?
Oh, I see. Here, take it as a function.
Yes. Yeah. So formally, it must be defined as a function over all y and x.
I see. Not the value.
So what would we expect the capacity to be? How many bits per channel use are we getting, do you think? 1. So I stick in a bit, I get out a bit. So we expect capacity to be 1.
What's the physical meaning of capacity? As you just said, you send 1, you get 1. How did you interpret this? I understand the mathematical side, but how should one feel about it?
So here's a way to think about it. So here's our message set. Let's say there's a power of 2 messages. Actually, let's choose a specific value, 2 to the 3rd. So I can express those messages in binary easily. So for each, in other words, if I send any element of this message set, I receive exactly the same thing. So each of these is a message bit. For each message, I have 3 message bits. So my rate, my capacity, is expressed as the maximum of message bits per channel use. So for each of these messages, I'm sending 3 message bits in 3 channel uses, and the other key factor here is that the end-to-end probability has to be probability of error in transmitting a message has to be 0.
But what you call channel use is the source message.
Correct.
For example, so you send, let's say, 4, then you send 3 bits. You send 1 source and you send 3 bits, then I would expect that C to be 3.
But how many bits are there in the message?
3, and
3.
You send 1 value. Channel use is single value. 4.
No, the channel use is defined with respect to this alphabet.
Oh, I see.
So each time I send one of these symbols, that's a channel use. Not each time I send a message, but each time I send one of these channel inputs. So 3 message bits and 3 channel uses, probability of error is 0, so we should expect this to be 1. And there's no way it can be more, because if it were more, then we would somehow be sending a certain number of message bits in fewer than 3 channel uses, but that would introduce ambiguity, so there's no way that can happen. So the maximum that I can see that this could be is 1. So we would expect this to be 1. So let's calculate mutual information. We have h of x plus h of y minus h of x and y. To make things a little easier, I'm going to do the following. I'm going to say, remember back when we talked about joint entropy, I can break this up into conditional entropy. I can say this is equal to h of y given x plus h of x. So therefore, this is equal to h of y minus h of, excuse me, let me write this explicitly, h of x plus h of y minus h of y given x minus h of x. So this cancels with that, and I get this is equal to, let's write it up above, mutual information is h of y minus h of y given x. Okay. First off, what do you think h of y given x is? So, the interpretation of that entropy, the interpretation of entropy is uncertainty. So, knowing x, how much uncertainty is there in y? I know that x is equal to y, so it stands to reason that should be 0. In fact, let's calculate it. So h of y given x is the sum over p of x, sum over x, p of x, sum over y, p of y given x, log 1 over p of y given x. So, I can simplify this a bit by taking the sum over x, p of x, and then summing this over two elements, y equal to x and y not equal to x. So whatever the value of x is, the first term will be y, or one term will be y equals x, and the other term will be y not equal to x. Actually, sorry, let's write it like this. P of y equals x given x, log 1 over p y equals x given x, plus p of y not equals x given x, log 1 over p y not equals x given x. Oh, by the way, let's define 0 times log infinity as 0.
So what are these values? I can't see it well. The log 1 over, so I'm sorry.
I'll write it on a different line. This is p y equal to x. So I can sum y over the value of y that's equal to x and the value of y that's not equal to x.